So in this video, we are going to be looking at the Newton's backward interpolation method using this question. To watch the previous two videos on interpolation generally and the Newton's forward interpolation, do well to look at the description of this video and you will find a link to those amazing videos. So this question says, form a difference table and find the value of f of x when x equals 1925. So you're given this table with the values of x and y, and I said in the first video the values of x are called the arguments, whereas the values of y are called the entry. So f of x is same thing as y. Now you have different values of x, which includes 1891, 1901, 1911, 1921, and 1931. And the values of f of x given to us, which invariably is y. The values of y given to us here includes 46, 66, 81, 95, and 101. Okay, so I said in the first video, in order to know which of the methods to employ, whether backward or forward interpolation method, the first thing you need to do is to consider the consistency of the interval, whether the interval is consistent or not, if it is changing or it is an equal interval. Now, what is interval? Interval simply means the difference in successive values of the argument. So it is always the value ahead minus the value behind, value ahead minus value behind. If this interval, if these differences gives us the same result, then it means that the interval is consistent. And if it is consistent, then we can employ either the Newton's forward or backward interpolation method. So let's find the interval now. Our interval is simply h. So h is equal to, now you can pick any of them, always forward minus the number behind. So you can simply choose 1901 minus 1891. Let's see what this value is going to give us. 1901 minus 1891, that simply gives us 10. So our interval here is 10. Now if you want to try again, you can punch 1911 minus 1901, it still gives you 10. You can also try 1921 minus 1911, it also gives you 10, and so on. So since the interval is consistent, it simply means that we are to employ either the Newton's forward interpolation method or the Newton's backward interpolation method. Okay, then again, in order to know more specific which method to use, then you consider the value of x which you're interpolating. If it lies at the forward of the table, then we use the Newton's forward interpolation method. But if this value that you're interpolating lies at the back of the table, then you use the backward interpolation method. Now, how do you know which is forward table and which is the backward table? Simply bisecting the table of values into two. So excluding x and f of x, the table that contains real value includes 1, 2, 3, 4, 5. So if it is 5, it simply means that, okay, so it simply means that this is now the center of the table. Since we have 1, 2, 3, 4, 5 columns, it means this can be the center of the table. Now, the table of numbers from beginning to the center of the table, this is the forward table, whereas table of numbers from the center to the end of the table is called the backward table. So we want to interpolate the value of f of x when x is 1925. So you see that 1925 lies between 1921 and 1931, and 1921 and 1931 lies at the back of the table, just at the very back of the table. So which means we are going to be employing the Newton's backward interpolation method. Okay, so the value we are interpolating x equals 1925. All right, now remember earlier I showed you guys a formula and I said our v is simply given as x minus xn all over h, where x is a value to be interpolated, h stands for the interval, and xn simply means the last value of the argument on the table. So usually the first value here of x is termed x naught. Okay, this is termed x naught, this is termed x1, this is termed x2, this is termed x3, and the last value, which is x4, is termed xn. So this last value is actually termed xn. Same thing as y, the last value of y is termed yn. So the first value of y is termed y0, second value of y is termed y1, third value of y is termed y2, fourth value is termed y3, fifth value is y4, which can otherwise be called yn. Same thing happens with the values of x. First value of x is termed x0, second value is termed x1, third value is termed x2, fourth value is termed x3, and the fifth value here is termed x4, which can also be called xn. So the very last value of x in the table is called xn. So let's find v now. So you recall v is equal to x minus xn all over h. So this is equal to, where x is the value to be interpolated, which is 1925. So you have 1925 minus xn simply stands for the last value of x on the table, which is 1931. So minus 1931 divided by h. H is the interval obtained here as 10. So divide by 10. So let's see what we are going to have. 1925 minus 1931. This simply gives us negative 6 divided by 10. So this implies that the value of h is equal to 6, negative 6 divided by 10. That gives us negative 0.6. So we have this to be the value of v. Okay, so we found the value of v, we found the value of our interval h. Okay, and we know our value of x, which is to be interpolated. We also know yn and of course xn. Okay, so having known all these values, let's now fall back to the Newton's backward interpolation formula. So if you take a look at the formula, yn, already we know what yn means, the last value of y on the table. We found what v is. Now we need to find what this delta yn minus 1, delta squared yn minus 2, and so on, what it means. Now those values are obtained from what is called the difference table. So we are going to be now plotting a difference table representing this information, and then find successive differences in the values of y. Okay, so let's move to the difference table now. So this is what our difference table looks like. Now we find different values or difference in the successive values of y. The first difference is termed delta y, which means y1 minus y0, followed by y2 minus y1, followed by y3 minus y2, followed by y4 minus y3. And that's it. So you keep on subtracting until only one value of difference is left on the table. So let's do this and see. Y1 minus y0 becomes 66 minus 46. So you put the answers at their middle. Okay, 66 minus 46, that simply gives us 20. That simply gives us 20. Okay, so you have 20. Next you do y2 minus y1, which is 81 minus 66. 81 minus 66, this simply gives us 15. Okay, so you put the answer once again at their middle. This gives us 15. Next you do 93 minus 81, also put the answer at their middle. So we find 93 minus 81. This gives us 12. You have this to be 12. Okay, next you find 101 minus 93, also answer at the middle. So we find 101 minus 93. This simply gives us 8. Okay, so you have 8. So the value of difference obtained so far is called the first difference. Okay, so we've obtained the first difference. we still carry on. We have to find these differences until only one difference is left. So we'll perform the second difference labeled as delta squared y, which is the second difference. Once again, it becomes now delta y y1 minus delta y naught, delta y2 minus delta y1, and so on. So it's always the numbers ahead minus the previous numbers. Okay, so we have 15 minus 20. Also answer should be written at their middle. Now 15 minus 20 simply gives us negative 5. We have negative 5. Then again we have 12 minus 15. Okay, answer also at the middle. We have 12 minus 15. 12 minus 15 simply gives us negative 3. Okay, then we'll have 8 minus 12. 8 minus 12, and 8 minus 12 simply gives us negative 4. Okay, so we continue doing this difference until just a single value of that difference is left. Okay, so we find the third difference now. So we'll find the third difference labeled as delta cube y, and this is going to be negative 3 minus negative 5. Also, answer should be written at the middle. So negative 3 minus negative 5. Remember, negative 3. Now, minus negative 5. Minus minus becomes plus. It becomes negative 3 plus 5. Okay, it becomes negative 3 plus 5. And that would simply give us 2, positive 2. Similarly, here you have negative 4 minus negative 3. So negative 4 minus negative 3 becomes plus 3. And this will simply give us, answer should be written at the middle. This will simply give us negative 4 plus 3 is simply negative 1. And you have this. So since we still have two values of difference, we have to compute this difference until only one value is left. So we'll carry on with the fourth difference now. Okay, you carry on with the fourth difference, which is labeled as delta fourth y. You have delta fourth y. Okay, also answer should be written in between. So this becomes negative 1 minus 2, minus 1 minus 2, and that simply gives us negative 3. Okay, since we have just one value of the difference left now, we can end our difference table here. Okay, so we end our difference table here. Now, since we are making use of the Newton's backward interpolation, then we simply pick out the values that are at the back of the table, the leading backward difference. These values are called the leading backward difference. Okay, so you simply pick out the leading backward difference. Okay, you simply highlight this. These are called the leading backward difference. Okay, now these values are called the leading backward difference, whereas the last value of y, notice that this is the last value of y, we call this yn. The first difference is labeled as delta yn minus 1. Second difference here is labeled as delta squared yn minus 2. Third difference here is labeled as delta cube yn minus 3. And fourth difference here is labeled as delta fourth yn minus 4, please. Yn minus 4. Okay. So if you take a look at the formula, you can see that we have been able to reproduce the values of these deltas. So we know yn, we know delta yn minus 1, we know delta squared yn minus 2. Now, since the table ends as delta fourth yn minus 4, then it means our formula is going to end here. Had the table extended up to delta fifth, okay, up to the fifth difference, That means we would have modified this particular part of the equation and appended v plus 4 over 5 factorial multiplied delta 5 yn minus 5. But since the table ends at delta 4 yn minus 4, then we simply end our formula here. So we are going to be paying attention to total formula from here to this point alone and discarding every other formula. All right. So let's see now. Remember from the formula, y is equal to yn. So let's write out everything now. So we have y to be equal to yn, and yn simply means what? The last value of y, which is 101, plus, let's fall back to the formula again. Now you have plus, you have v over 1 factorial multiplies delta yn minus 1, and we found the value of v earlier. We obtained v here to be what? Negative 0.6. We obtained v to be negative 0.6. So you have plus negative 0.6 over 1 factorial multiply delta yn minus 1, and delta yn minus 1 here is what? 8. So multiply by 8. Okay, so as I said earlier, these values are called the leading backward difference. So these are the values we are using. Whereas if you are picking from the front of the table, then these values are called leading forward difference. That is when you're going to be employing the Newton's forward interpolation. Please do well to look at the description of this video. You will find a link to a proper explanation on the Newton's forward interpolation. All right. So next thing in the formula, let's pull out the formula again. Next thing in the formula is v multiplies v plus 1 over 2 factorial multiply delta squared yn minus 2. Okay, so once again, what is v? You have plus v is negative 0.6, v times v plus 1, which is negative 0.6 plus 1, all over 2 factorial multiply delta squared yn minus 2, and delta squared yn minus 2 simply gives us here negative 4. So which means we're multiplying this equation by negative 4. Okay, now let's fall back again to the formula. Now you have, after the second difference, you have plus v multiply v plus 1 multiply v plus 2 all over 3 factorial multiply delta cube yn minus 3. Okay, so again you have plus v itself is negative 0.6 multiply v plus 1 negative 0.6 plus 1 multiply v plus 2 negative 0.6 plus 2 all over 3 factorial multiply delta yn minus 3, and delta yn minus 3 multiply delta cube yn minus 3, and delta cube yn minus 3 simply gives us here negative 1. So multiply by negative 1. So we're multiplying the whole of this equation by negative 1. Okay, and finally for the fourth difference, you have v multiply v plus 1 multiplies v plus 2 multiply v plus 3 over 4 factorial multiply delta fourth yn minus 4. Okay, so basically the same thing, just repeating the formulas and then adjusting in case of the power of the difference. So now we have plus v, so this is plus v itself is negative 0.6. Okay, I think I can pull this down. Let's pull this down, please. So we can pull this down over here, plus negative 0.6 times negative 0.6 plus 1 times negative 0.6 plus 2 times negative 0.6 plus 3 all over 4 factorial multiply by delta fourth yn minus 4, and delta fourth yn minus 4 gives us negative 3. So which means you're multiplying this equation by negative 3. Okay, so multiplying that equation by negative 3. Okay, so let's reevaluate this and see. All right, so we stopped at here. So y is equal to 101 plus negative 0.6 multiplied by 8 over 1 factorial plus negative 0.6 multiplies negative 0.6 plus 1 multiplied by negative 4 divides 2 factorial plus negative 0.6 multiplies negative 0.6 plus 1 multiplies negative 0.6 plus 2 multiplies negative 1 all over 3 factorial plus negative 0.6. Basically, what we just did previously. Now, this implies that y is going to be equal to, so remember, put down 101. Now, negative 0.6 multiplies 8. This gives us negative 4.8 all over 1 factorial simply means 1. Okay, plus, now we have negative 0.6 multiply negative 0.6 plus 1. This gives us 0.4. So multiply 0.4 multiply by, we have a negative 4. So multiply by negative 4 all over 2 factorial. 2 factorial simply means 2 times 1, which is equal to 2. So which means we're dividing this by 2. So we come down here now, plus we have negative 0.6, not forgetting negative 0.6 multiplies negative 0.6 plus 1. That is simply multiplying by 0.4 multiplies negative 0.6 plus 2, which is 1.4 multiplied by, we have negative 1 here, so multiplies negative 1 all over 3 factorial. 3 factorial simply means 3 times 2 times 1, and that is 6. So divide by 6. Okay, so let's see 4 down plus now we have a negative 0.6. Negative 0.6 multiplies negative 0.6 plus 1, which gives us 0.4 multiplies negative 0.6 plus 2, which gives us 1.4 multiplies negative 0.6 plus 3. This gives us 2.4 multiplied by, we have negative 3 here, so multiply by negative 3. You have this divides by 4 factorial. 4 factorial means 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 24. 24 times 1 24. So we're dividing this by 24. Okay, so this means y is going to be equal to, remember, you put down 101. Now negative 4.8 divides 1 remains negative 4.8. So let's evaluate this numerator. Negative 0.6 multiplies 0.4 multiplies negative 4, and see what that will give us. So negative 0.6 multiplies 0.4 multiplies negative 4. That simply gives us plus 0.96 divided by, of course, divide by 2. So if you're wondering why it is positive, negative here multiplied by this negative becomes positive. So you have this multiple to give us a positive result. Now let's evaluate here. Negative 0.6 multiplies 0.4 multiplies 1.4 multiplies negative 1. Again, negative 1 cancels out, so you're going to be having a positive result over here. So let's find 0.6 multiplies 0.4 multiplies 1.4 multiplies 1. This simply gives us positive 0.336. So you have plus 0.336 divide by, we have a 6 we have here 6, so divide by 6. Okay, so let's evaluate here. Once again, negative and negative obviously will give us a positive result. So we should be expecting a positive result here. Now 0.6 or negative 0.6 multiply 0.4 multiply 0.4 multiplies 1.4 multiplies 2.4 multiplies negative 3. This gives us positive 0.8064, not forgetting divide by 24. So divide by 24. Okay. So let's evaluate all these values now. Y is equal to 101 minus 4.8 plus, let's find 0.96 divided by 2. This simply gives us 0.48 plus 0.48 plus, let's find 0.336 divided by 6. 0.336 divide 6. This simply gives us 0.056. We have plus 0.056. And finally, let's find 0.8064 divided by 24. 0.8064 divides 24. This simply gives us 0.0336. Or we have 0.0336. Now let's evaluate all. This simply implies that the value of y is now going to be, so we have 101 minus 4.8 plus 0.48 plus 0.056 plus 0.0336, and this simply gives us 96 points. We have 96.7696 approximately, and this is the value of y when x equals 1925, and that becomes your final answer. So this is the value of f of x when x equals 1925. I hope you find this video very interesting and helpful. Please, if you do, I would like to get your thoughts in the comment section. Do well to like the video, share to your friends, comment nicely, and of course, if you're new to the channel, do well to hit the subscribe button and turn on your notification bell so you don't miss out when our subsequent videos drop. In the next video, we are going to be looking at the Lagrange interpolation method. I hope to see you in that video. Thanks.